All right. Now, if round 4, algebra, kind of got you flustered, well, here we go again with round 5, which is trig, right? Sine, cosine, tangent. This is pre-calculus. And then we have this a squared plus b squared equals c squared, which is that whole Pythagorean theorem guy. This is going to be, well, it's all important, guys. I mean, not as important as like life things, but I mean, this is going to be pretty critical to succeeding in the class, particularly with a material on exam 2, where we start talking about forces and direction of forces and finding components of forces. Vectors. All right, we're going to be doing lots and lots of vectors. So this is where we're going to review that here. And if you're rusty, that's okay. You'll catch up, you'll review. Otherwise, you're going to really need to get help sooner rather than later. And it's true for this whole class. As soon as things are really starting to not pile up, as soon as things start to get a little fuzzy, go get some help. There's free tutoring services. There's office hours. Come to office hours, right? Go to the tutoring services. So many opportunities for y'all to get some help, right? Okay, sine, cosine, tangent. Have to deal with these right triangles. Right triangles are triangles that have right angles. Right angles being 90 degrees, right? And then depending on the angle you're talking about, that angle in the sine, cosine, tangent are related to the ratios of adjacent, hypotenuse, and opposite sides of the triangle. So you have to identify, is this a right triangle? Then you have to identify what angle am I talking about, and then we have to identify what are the opposite, adjacent, and hypotenuse sides. The hypotenuse is usually the easiest to get, right? The hypotenuse is always the one that is opposite of that 90-degree triangle. Now, the adjacent and the opposite here are based on the angle provided, right? So we can see here that the angle for the first triangle is in that top left. The angle for the middle triangle is in the bottom right. So it's going to be something that is dynamic. Things are changing depending on what angle you are considering. But once you have that angle identified, you should be able to identify the opposite very, very easily, right? The one that's the farthest away. Right. So this would be opposite, this would be opposite. Once you have two of the sides identified, that leaves you with the third one, right? And the third one is going to end up being the adjacent, right? The adjacent is the one that's right next to it, right? It's connected to the angle, right? The hypotenuse makes up kind of one side of the angle right here. There's your angle theta, there's your hypotenuse, there's your adjacent, right? There's your angle, there's your hypotenuse, there's your adjacent. So the hypotenuse and the adjacent are always, connected to each other with respect to that angle we're talking about, okay? Try to do that last one on your own. Give it a pause, give it a try. And here we go. Opposite of 90 degrees is hypotenuse. There's my angle theta here. This is your opposite. This is your adjacent. Well done. All right, now you see, here's our yield sign again. Dr. Ray, do I have to do all of them? No. We're going to work through two of them, and then I'll give the last one for you to do here. All right, for given right triangles, right? Solve for the unknown, right? The question mark that I have here. Given that the angles here are theta 1 equals this, theta 2 equals this, or the r values are in, y values are given. Okay, so we'll work through the one on the left here first. Kind of scooch my way to the left of the page. I'm trying to solve for x. All right, so here's x, and I'm given r, and this is my angle theta. All right. What do I do? What do I do? What do I do? Well, what did we do in the previous number? We identified sides here, right? Okay, we can start there. There's the right angle, which would make this the hypotenuse. Very good. Here's my angle. That would make this side right here the opposite. Very good. And that would mean this one is the adjacent. Okay, so now with all these things, what are we given? What do I not know? And then what trig function is going to help me solve for my unknown, right? I'm looking for the opposite. And when I come up to my trig functions, I see opposite is in sine and opposite is in tangent. All right, so if I'm trying to solve for this value right there, I would have to know the hypotenuse and I would have to know the angle. If I were to use tangent, that means I would have to know the adjacent and I would have to know the angle in order to solve for the opposite. Okay, so trying to solve for opposite on this first one here. Do I know the hypotenuse? I do, it's given. It's this value r. Right? Do I know the angle theta? I do, it's theta 1, and that's given. So I know those. So I can use sine theta equals opposite over hypotenuse to solve for that unknown. Tangent theta. Do I know theta? I do. It's that value given. Do I know the value of the adjacent? I don't. Right. Now, so that means that initially I can't use that. Could I solve for that adjacent? Sure, we could. We could use Pythagorean theorem, which is number 3. But if you're ahead of the game, hey, you could do that, but try to work smarter, not harder, right? We have all the information we need with sine. So here's what I'm going to do. I'm going to rewrite this, right? I have sine theta is equal to opposite over hypotenuse, right? But my sine, my theta is theta 1. My opposite is that unknown x value, and my hypotenuse is this known r value. Now we're back to algebra, guys. How do I solve for that unknown x value? Well, x is being divided by r, so I have to multiply by r on both sides. So you end up with x is equal to r times sine times theta 1. Plug in our values, we get x is equal to 10 meters times sine of 60 degrees. There we go. And you get a value with that. All right, I'll plug in the value. Am I in degrees? I am in degrees. Make sure your calculator is in degrees. So you get 60 times sine is 0.886. I take that times 10. I shouldn't have to do that. It's just 0.87 essentially. 8.7 meters. Meters, right? That's the unit. And there we go. All right. Move on to the next one here. Blue, blue, blue. No, we'll use blue. We'll use green. Now the unknown in this one is the angle. We don't know what angle phi is, right? It doesn't tell you what phi is. It says theta 1 and theta 2 are these values, but it doesn't tell me what that angle phi is. So how do I solve for this angle? All right. Well, what am I given? I still need to use one of these equations up here. I'm going to erase because now we're back to the drawing board. I want to solve for the angle. Well, let's identify all the pieces. This r value here is the hypotenuse, opposite of the 90-degree angle. This is my angle of interest. Opposite of that is my opposite. And adjacent to that is the adjacent, right, Dr. Ray? Oh, I forgot units, 4 meters. Shame on me. Okay, so it looks like I don't know the opposite. I know the hypotenuse and the adjacent. So once again, let me go to highlight. I'm trying to solve for the angle theta. I could use any of these to solve for the angle theta. Right? If I were to use sine, I would need to know the hypotenuse, which I do know, but I do not know the opposite value. It's not given. Right? Could I solve for it? Yes, you could use Pythagorean theorem and then use sine. But let's roll through the others first. Right? Let's look at tangent. Tangent also uses opposite. Can't use tangent. What about cosine? Cosine means I need to know the adjacent value, which I do, and I need to know the hypotenuse value, which I do. Okay, so then let's roll with cosine. Cosine of phi is equal to the adjacent over the hypotenuse, right? That's just the equation right there, right? Or I guess I can go back. Cosine of theta, right? I'm just copying what I have up above. Is adjacent over hypotenuse. Now I'm going to apply that to my triangle here. Cosine of phi is equal to my adjacent, which is the value for y, divided by my hypotenuse, which is the value for r. Okay, now I'm trying to solve for this phi. And it may have been a while, but how do I get rid of that cosine? That cosine is a trig operator, right? I can't just divide by cosine. But what I'm going to do is I'm going to multiply by the inverse. Very similar to like a division, but I'm undoing the operation. So what you do to one side, you have to do to the other side. So I'm going to write this in whatever this color is. Oh, no, I'll use lavender. Okay. So what this is called arc cosine or inverse cosine, if you want to say that. Inverse cosine of, I'll go back to green, right? Cosine of phi equals, and I have to do that to the other side too, arc cosine of this whole quantity y over r. All right, very good. Now what happens to this left-hand side is the arc cosine and the cosine go away, leaving you with that value of phi, the value of the angle, right? And that's going to equal this arc cosine of y, which is 4 meters, divided by r, which is 10 meters. Right, notice the meters will divide to 1, and you end up with the arc cosine of 4 over 10. So that's 0.4, 4 over 10, 0.4. And now usually on your calculators you have to push like second cosine. This is 66. 66 degrees. Okay. Those are our basics, guys. I'm not saying that this is going to cover every single problem, right? But these are your basics. How do you solve for angle? How do you solve for a side? And now you get to try it on your own, right? Very good. But we're not done with this, right? After this, there'll be another quiz question. I'm sure that pops up. Number 3. For the given right triangles, solve for the unknown side length. An old acquaintance noticed Pythagorean theorem may be helpful, and if you don't have it from up above, yeah, it's that whole, I guess I'll say a squared plus b squared equals c squared, or often what you'll see in physics is x squared plus y squared is equal to r squared. Notice I'm typically using r for that hypotenuse, x to be the lengths that are going left and right, those sides of the triangle that are going left and right, and we're using y for those sides of the triangle that are going up and down. All right, so once again, I'll help you out with that first one there on the left, and you'll do the one on the right. All right, so solving for r, given the sides for x and y. So x squared plus y squared equals r squared, trying to solve for what r is. How do I get r by itself? Well, if I'm squaring something, I need to undo the square. That's a square root, right? So you can write this two ways. First way that I could do it is I could just do the square root of both sides, as you probably have seen before. So the square root gets rid of the square, and so you end up with r is equal to x squared plus y squared square root. Right. The other way that you could write this, right, is I'll say r squared, right? How do I get rid of that one, that squared in the top? Well, I'm going to multiply this. I'm going to do an exponent to the exponent, right, to the 1/2, right? So I'm taking r squared to the 1/2 power. So this goes down here, and you get 1/2 times 2, right? Because when you exponent your exponent, those exponents multiply. Math rules, guys. 1/2 times 2 is 1. So you get r to the first power. And that's exactly what we want, solving for r by itself. Then you get x squared plus y squared, and this goes to the 1/2 power, which is the same as taking the square root of it. Don't believe me? Type it into your computer. Do 4 and then do square root. It'll get you 2. And then do 4 to the parentheses 0.5, or just exponent 0.5. My guess, you'll get 2. All right, before I cut you loose to do that last one, a brief note on significant figures and scientific notation. They're super helpful, super important. You may get asked some questions that involve sig figs. So make sure you kind of know the rules for those. Particularly, they're important when it comes to lab, right? Though we don't focus on that necessarily at the beginning of lab. We're trying to help you learn content through that lab and learn how to use tools to analyze, right? So make sure you know the rules, familiar with how to use scientific notation, 10 to the second, 10 to the third, 10 to the sixth, kilometers, kilograms, etc., and make sure you know, like, hey, I don't need to put in 1,000 decimal pieces or even 4 decimals. If it's 1,269.2379, chances are the 0.2379 aren't going to matter, right? So just be careful. Try to review those rules in the book, and now try to answer how long the side x is in that question right there on the right. All right, everybody. Congratulations, you're almost done. Good job.